So hello students. So in this video we are going to see what is Thevenin's theorem, what are dependent sources, and how we can solve the circuit using Thevenin's theorems for dependent sources when the circuit has dependent sources. So you can see here in this circuit there is one dependent source, the source which is dependent on some value like this. So this is nothing but the dependent source. So whenever any circuit has dependent source, then there's a different method of finding the reducing the circuit using Thevenin's theorem. Let us see what are the steps here. So as we know, what is Thevenin's theorem? Thevenin's theorem has to reduce the circuit in only one voltage and one resistor, and that we do by first finding VTH. Suppose we want to find the current across this 16 ohm. So we have to open this and find the open circuit voltage, that is open circuit voltage across this, that is VTH. Then the second is, that is what we do here, we just open the, because the question is find the current through that, so what we do is we open that terminal, and that is nothing but the voltage VTH. We find VTH. That is the same as we do for the independent sources also. Second step, what we do in independent sources is we find the RTH. RTH is what? We short circuit the voltage source and open circuit the current source, and we find RTH at this side. But in this case, we cannot open circuit the voltage source because it is depending on some other current. So we can't find RTH directly. So what we do here in this case is, we cannot find RTH. We can write here, we can't find RTH directly. So in this case, what we do is we find ISC. ISC is the short circuit current at this point, where we are finding VTH. And why we are calling it as short circuit current? Because we are going to short circuit that branch. So this is same here, this 6 ohm, and this we are shorting. This is 4 volt, 10 ohm, this is 6 ohm, and this is 0.58 IX. So this we are shorting. So this way we first find VTH, then we find ISC, then we write the third step is RTH equals to VTH upon ISC. And then once we get RTH, what we do is we draw the Thevenin's equivalent circuit. And what is that? VTH and RTH. So we are reducing the circuit across the terminal where we are going to find the voltage or current in this. So this is Thevenin's equivalent circuit. I'll repeat the steps. First we find VTH by opening that terminal. Then as we can't find the RTH directly, we have to find ISC by shorting that branch. And thus RTH can be got by VTH upon ISC, and then after getting this we can draw the Thevenin's equivalent circuit. So let us start solving this problem. In this problem they are asking this, determine the current through 16 ohm resistor using Thevenin's theorem. So first is we have to find VTH for this circuit. So let us start for this, how to find VTH. So you can see this is IX, and we are opening this. IX is nothing but the current, and this dependent source is depending on this current. Now in this circuit, when you are finding VTH, so first we are finding VTH. Let us start with the first step, VTH, and let us draw the circuit again. 4 volts, 10 ohm, 0.8 IX, 6 ohm, and this is open, and this was IX actually. The voltage is VTH. Now when you are finding VTH, you can see that you are opening this terminal, and thus when you open this, what is the value of IX here? It is 0. So when we say IX is 0, that means this also will be 0, because this is depending, we can't break directly 0. But when this is 0, what will be Ix? Here, this also will be 0. That means this will be open. Now what we can say, when this is open, what this becomes? 4 volts, 10 volts and 6 ohms directly. This gets opened. Now this is VTH, this voltage. So when this is open, there is no current flowing here. The current is 0. And when the current is 0, can I write that VTH is 4 volts directly? Because the current is 0 and we are not making current directly 0. We have seen that first that Ix is 0. And when Ix is 0, we are opening 8.8 Ix and thus VTH is 4 volts. Right? So this is done. VTH is 4 volts. Now let us start with next step, that is ISC. Now for ISC, what you have to do? You have to short circuit that branch. So I am just drawing it again. And this is short circuit, 0.8 Ix. This is 10 ohm. This is 6 ohm. And this is short. So 4 volts. And this is now. This is Ix again. But this is not the same Ix which we got through Thevenin, this VTH. Because there's that when we are finding VTH, we are opening that terminal. But now we are shorting. So this Ix will be different. Now what will be Ix when we are shorting it? We don't know the value. But we can find out the value of Ix. Ix is nothing but here ISC. We can say this is same as ISC. Now we can find this value. How we'll find that value? Is we can apply here. This one is KCL, this node. We can call it as P. So we can apply KCL at node P. And what is KCL says? The sum of all currents, outgoing currents is 0. So if I take this current as this voltage will be, this is short, so this is 6 ohm. This is voltage Vp and this is 4 volts. Instead of writing that, what we can do is, this is 0.8x and this is Ix. So what will be this? This will be 1.8 Ix. Because Ix is going here and 0.8 is going here. This current will be 1.8 Ix. Now we will not apply KCL, we will apply KVL in the outer loop. That will be easier. What it says that 4 KVL, 4 minus 10 into 1.8 Ix. I am applying KVL in the outer loop. So plus 4 minus 10 into 1.8 Ix minus 6 into Ix. Because Ix is going through this branch, so minus 6 into Ix equals to 0. So 4 minus 18 Ix minus 6 Ix equals to 0. It goes there. 4 equals to 24 Ix, and what is Ix? 4 by 24, or we can say 1 by 6 ampere. And Ix is nothing but ISC, so we can write here ISC equals to 1 by 6 ampere. 1 by 6 ampere. So we got VTH is 4 volts and ISC is 1 by 6 amperes. So now we can find out RTH. So what will be RTH? RTH will be VTH upon ISC. This is the third step. We got ISC is this. So RTH, VTH is 4 volt, ISC is 1 by 6. So RTH I am getting is 24 ohms. Right? Now RTH we got. Now the fourth one is equivalent circuit. Thevenin's equivalent circuit. Thevenin's equivalent circuit. So that says that this is VTH, 4 volts, right? Then RTH, that is 24 ohms. 24 ohms, and then we have to bring back the voltage, the resistor which was there, that is 16 ohms. So what is that? Now we want to find this current. The question was this. So find the current through 16 ohm resistor. So I equals to 4 upon 24 plus 16, that is 4 upon 40, and thus we can say it is 0.1 ampere. 1 by 10, that is 0.1 ampere. Right? So this way we can say we got the I for this 0.1 ampere. And the steps again I'll repeat. First we have to find VTH by opening the terminal. This is the first step. Second step is ISC by short circuiting that branch where you are finding the current or voltage. Third is RTH, is VTH upon ISC. And fourth is Thevenin's equivalent circuit. And thus we can find the current or the voltage. So thank you. Any queries, please write in the comment.